So today we are going to see about the complements. Actually, these are the major things. Like complements are very essential, but I think it's not mentioned in your syllabus. But even though it's a major topic, so where it is used in each and every digital design concepts. Okay. So what we'll see, already we discussed about one's complement. I told you about the one's complement. Okay. So we'll see the different kinds of complements here. Okay, so we'll start with the complements and we'll see how the subtraction is performed with the help of these complements. Okay, so 1 minute. So I have a problem sharing the screen. 1 minute. So have you done your assignments? Assignments అయిపోయినాయా?
Sir.
Yeah. So you're clear about those topics, right? So Hamming codes. Yeah. Hope you are clear. So if you have any doubts, just message me personally also, right? So if you are, you can respond in chat box or you can mail me. So you have the mail, right? So you can mention all those doubts and they can mail that also. Okay. So today's class we will see about the complements. Right. So I think there will be disturbance, but you know, right? So complements. Okay. So there are two complements here. Two kinds of complements. So radix complement and diminished radix complement. Okay, so radix means if I say this R, okay, so R is R's complement. If I say this is R's complement, so diminished radix stands for R minus 1's complement. R minus 1's complement. Okay, so the procedure we'll do here is like we can easily find this R minus 1 complement first. So this we can find the diminished complement. Okay, and so we can find this R minus 1 complement first and add 1 to the R minus 1 complement. So it will through which we'll get R's complement. Okay. So what is the purpose of this complement? So I'm talking about these complements here. So what is the purpose of using these complements? Okay. So actually we need complements because you know so each and every digital circuits or each and every systems. So what we discuss in day-to-day life. So we should always think about the simplification of the processing. Okay. So take your computers, take your mobile phones. So whatever the things, whatever the updations. Okay. So updations we come across. Earlier we used to have CRT monitors, and now we are using LED monitors, and the before we'll be using LCD monitors and earphones. So every technology is updated. Okay, so why we do these updations? Because we want to make use of the technology in a better way and to make use of the system. I mean, so in order to simplify the things here, in order to simplify the things. So whatever we do, so we want to simplify the things and we want to make the things easy for our life. Okay, so whenever you are using mobile, earlier they were used to have keyboards, keypads. Okay, so now we are using touch because we want, I mean, using touch, the usage is very easy. Okay, so the systems are updated every time. So we have to go for the optimizations. We have to improve the systems day to day. Okay, in the same way, so when I talk about the digital systems, so if I'm adding two numbers, definitely I need this adders. Okay, if I'm using some subtractions, I'll be using the subtractors. Okay, so generally what happens here is, so generally subtractors are costlier than adders. Subtractors are costlier than adders. Okay, so we are these designers or the scientists or the people who are working on this digital design or some other circuits, so they have find an alternate way for subtraction. Okay, they have find the alternate way for subtraction, and that alternate way for subtraction is using the complement method. Okay, so what we can do here is, so if I want to perform a minus b, so instead of performing a minus b, I'll take the 2's complement of so complement of b here and add that complement to a here. Okay, so instead of performing subtraction, what I'm doing here is, so take the complement of the other end. Okay, so take the complement of b and that complement is added to a. So we are doing the addition only, but what we are doing here is we are taking the complement of the previous one. Okay, so complement of b here. So we are avoiding the subtraction operation with the help of these complements. Okay, so which will reduce the circuits, which will reduce the cost of the circuit, and which will reduce the complexity of the circuit also. Okay, so that is the main purpose here. So to reduce the complexity of the circuit, to reduce the cost of the circuit. Okay, and we have find an alternative, so which is called as complement method. Okay, instead of using subtraction, we'll go for the complement method. Okay, are you getting my point? So please respond. Are you getting my
Yes,
point?
sir. Yes, sir.
Okay, yeah. So we'll be using complement as an alternative to the subtraction. Okay, we'll be using the complement method as an alternative to the subtraction here. So why we are using the complements as an alternative to the subtraction means, we'll be reducing the complexity of the circuit. We will be reducing the cost of the circuit. Okay, so when we use this reductions here, I mean obviously when we reduce the size of the circuit, obviously the cost of the circuit is reduced. Okay, so that is the main purpose here. Okay, so hence we'll go for the complement method. So we'll know what are the complements available here. Okay, so I said this r's complement and r minus 1 complement. R is the radix of the numbers we are using. For example, if it is like decimal number system, so decimal number system, r will be equal to 10. Okay, so in case of decimal number system, we'll be having 10's complement and the 9's complement. Okay, so in case of decimal number system, so we'll be having so 10's complement and 9's complement. That is rs minus 1 is 9's complement. Okay, so in case of binary number system, we'll be having the 2's complement and 1's complement. Okay, so in case of binary, we'll have 2's complement and 1's complement. Okay, in a similar way, we'll be for a hexadecimal number system, we'll be having 16's complement and 15's complement. Okay, so we'll be having r's complement and r minus 1's complement. Octal will be having 8's complement and 8 minus 1, that's 7's complement. Okay, so that is what we'll be having in case of this number systems. Okay, so we'll be having in case of the number system. So we'll see about this 1's complement and 2's complement initially. So actually we have all those formulas. I don't want to waste time with this formulas. Okay, so just I want straight away want to tell out the procedure here. Okay, so 1's complement, so a binary number. So already we discussed, right? So 1's complement of binary number is, so change 1's to 0s and 0s to 1's. So change 1's to 0s and 0s to 1's. For example, 1's complement of 10 11 000 is, okay. So what is 1's complement of this number? So what is 1's complement of this number? It is 0100
Triple one.
111. Okay. So this is 1's complement of this number. So in 1's to 0s and 0s to 1. Okay. So actually the procedure will be like this. So what I have to do here is, so I have to do like this. So 1 1 1 and we have 1 1 1 1 7 months. Okay, and minus 1 0 1 1 0 0 0. So I have to subtract the given number from all the ones here. Okay, that is 1's complement generally. Okay, so 1 minus 0. So generally what I'll get here. So I have to subtract the given numbers from the this one. 1 minus 0 it is 1, and 1 minus 0 it is 1. So 1 minus 0 it is 1. So 1 minus 1 0. So 1 minus 1 0. 1 minus 0 it is 1. So 1 1 it is 0. Okay, so this is a procedure generally. So subtract the given number from all ones here. Okay, we have to subtract the given number from all ones. So hence we are getting the complement of this one. So zeros are changed to ones here. So ones are changed to zeros here. Okay, so this is how we get the ones complement. Okay, suppose if I want the 2's complement here. So we got r minus 1's complement here. Okay, so 1's complement is nothing but this is the thing here. So this is r minus 1 complement. And if I want to get the r's complement, that is 2's complement, just add 1 to this result here. Okay, so adds 1 to the result. Okay, so what is the result I got here? So what is the result I got here? So it is 0 1 double 0 triple 1. Just add 1 to
Triple
this.
one.
Yeah. So add 1 to this. Add 1 to this in the sense add to add here. Okay. So 1 1 it is 0 and carry of 1. Okay. 0 and carry of 1. Okay. When I'm dealing with the binary, so the things will be like this. So 0 0 addition of 0 0 it's a 0. So 0 1 and 10 it's a 1. So addition of these two will give a 1. Okay, so 1 0 it is a 1. So 1 1 it is sum of 0 and carry of 1. We'll get a carry of 1 which is carried forwarded to the next one here. Okay, so this is, so 1 1 means it is a 0 1, and again it is a 1 1. It is again a 0 1. Again it is 1 1. It is again a 0 1. So this is 1 0 1 0. Okay, the final result is 0 1 0 1 triple 0. So this is the 2's complement of the given number here. Okay, 2's complement of the given number. So first find the 1's complement, just add 1 to the 1's complement, we'll get the 2's complement. Okay, so that is the concept of this 1's complement and the 2's complement. So are you getting my point?
Yes, sir.
Yeah, so it's very simple, but it's important also. Okay, the basic concept is, so 1's complement of a number is we'll get the 1's complement of a number by changing 1's to zeros and zeros to 1's here. So this is arrived because 1 minute. 1 minute. Right, so this is 1's complement and this is 2's complement. So take the another problem. So we'll see. So find the 1's complement and 2's complement of the given number. So tell me the answer. So 1's complement is
1 0 1 0 0 1 0, sir.
1 0 1 0 0.
1 0.
This is 1's
1
complement.
0
Add a 1 to this. Okay.
1 0 1 0 1 0 0 1 1.
1. So this is 2's complement. Okay, adding 1 to the this one. So it'll be confused whenever we get 1 1. So whenever I get 1 1, so it is nothing but in case of addition, it is 1 1, it is 0 and carry of 1. So that you have to remember. Right? So clear? So these are 1's complement and 2's complement. Now we see 10's complement and the 9's complement. Okay. So 1's complement. So we got 1's complement by subtracting the given number with all the ones. Okay, subtracting given number from all the ones here, and coming to 10's complement and 9's complement. So first of all, I'll start with the 9's complement. Okay, so find the 9's complement of so 1 2 3 9 8. Find the 9's complement of 1 2 3 9 8. Okay, so earlier what we had done, so in case of 1's complement, so what I have done, I subtracted each and every number from within 1 year. Okay, so each and every number is subtracted from, each and every given number is subtracted from 1. Okay, in case of the 9's complement, each and every number is subtracted with 9 year. Okay, so what I can do here is, so I can subtract 1 2 3 4 5 numbers. Okay, so minus 1 2 3 9 8. Okay, so 1 2 3 9 8. Okay, so what is the answer I get here?
87601, sir.
87601. So this is 9's complement. Okay, so 87601. Okay, so this is 9's complement. Okay, so in case 16's complement, if I say that 15's complement, okay, so 15's complement is subtracting all the numbers from 15, that is F. Okay, so if I want this as 15 complement, so this is 87601. Okay, so 87601. Okay, so this is 87601, and if I want the 10's complement, just add 1 to the 10's complement. Okay, just add a 1 to the 10's complement. Okay, so this is 87601. Okay, so this is 9's complement. Okay, and if I add 1 to this 9's complement, I'll get the 10's complement. So that is 8760.
87610.
60. You don't think like a decimal format. So decimal format is just normal addition. So don't think like binary 1 at a 0 okay. So decimal format 1 is 2, right? Because we don't have the option, right? So 9 were question. So 9 out of 10 we can go for carry 1 and this of 0. So this is 8760 to be the 10's complement. Getting my point? So this is decimal system. Okay. So 1 plus 1 is 2, it's not 0 1. So 9 plus 1, then we can go for 0 and carry. Clear?
Yes, sir.
Okay. The option is so 9's complement and 10's complement. The events we can form the addition subtractions operation. I don't know. Okay. This is
Sir, voice clear గా రాలేదు సార్.
anyone facing the same problem or only or is it not here? అందరికి same problem. So
Yes sir, same problem sir.
okay. So give me 5 minutes. I'll be logging back. Give me time. I'll logging. So am I audible? So if it is not clear, so we'll stop. No, we can continue on tomorrow or day after tomorrow. Because I'm also not finding convenience here. Okay, so we can go for Wednesday and Thursday. We can take some extra classes. So just I'll continue with this one or two concepts here. Is it clear or still not problem? Having a problem? It's okay. I can't continue this. So let's stop for today. Okay. So in the same way, just study. We will see the next sessions. Right? Yeah, I'll stop it for today because I'm not getting a proper signal here also. I don't know. I can't continue this class also. Okay. So meanwhile, let's study about these complements. So 9's complement and 10's complement and 15's complement and 16's complement. So 15's complement and 16's complement is nothing but so subtraction from 15 F. Okay. And 16 complement is nothing but so addition of 1 to the 15's complement. Okay. So we'll see tomorrow. See you then. Yeah. So drop your attendance. So we'll see tomorrow.